Hey folks, what's going on? Today we're going to be taking a look at feedback inside of TouchDesigner, in particular texture-based feedback loops. I've seen a lot of people asking questions about how to really overcome some of the challenges of working with feedback loops, and I think the biggest thing that you could take away when it comes to working with feedback loops is the mindset and how these effects get applied inside of a feedback loop. So we're going to be rebuilding this effect as well as actually showing you a couple of other really cool effects, really just to ensure that you're thinking about feedback loops in the way that's going to make it as intuitive as possible for you to create cool artworks in. So let's go ahead and delete everything in this network and quickly rebuild that example while we're talking through it. So the first thing I'm going to do is create a circle top here. And as we saw in that example, I kind of just had a circle that was moving around with some random noise data. So as I always do whenever I want to draw something like this, like a circle that is moving around constantly and updating its position, I don't actually do that on the circle top. The circle top is a generator, so that it generates a circle. And that means that updating it every frame is actually going to be slower than compositing it on a bigger canvas and updating its position inside of the transformation. So a really easy way we can see that is if I make my constant top here, I'm going to make this a 1280 by 720 resolution. So that way, even if you're on the free version, this will work well for you. I'll go back to the constant page of parameters, and I'll just drag that alpha to 0. So I have an alpha 0 background that I'm going to composite and move this circle around on top of during that composite stage. And this can be really easy to do with an overtop. Even something as simple as that, where I can take my circle, put it over my background here. And as always, I'm going to come to my overtop and make sure to set the fixed layer and pre-fit overlay. That's always like the first thing you want to do when working with compositing operators. In this case, I want my pre-fit overlay, which is just a fancy way of saying what should TouchDesigner do with the other layer that's composited and not the fixed layer taking the resolution. In this case, because my circle is only 256 by 256, it's getting set to fill mode by default. I'm just going to set that to native resolution. And that way it puts my circle right at the center here. So now we just need to create a really easy control scheme for it so it can kind of move itself around as we're working through our example. So what I can do is start by making a noise chop here. And a fun trick you can do with noise chop, if you go to the common page of parameters, by default what we have here is the output of 600 samples of channels. But if I set this to time slice, it's actually just going to scrub through that and give me a single value sample back, which is more what folks are used to when you're just getting started with TouchDesigner. So what I want to do here is actually I want an X channel and a Y channel, and I can go to the channel page here of properties. And a lot of people don't know, but you can actually make a space-separated list of channel names here, and it'll actually generate noise for both of those channels, which is very convenient, so then I don't have to make multiple noise tops, or noise chops in this case. So I think everything else on the noise is all right. We've got some random moving data here. I know that I'm almost certainly going to have to scale that data range, because noise often by default is going to have a from range of -1 to +1. And actually I can even go over and see what my to range is going to be here on my over. So inside of my over top, I can go to the translate, and I can even just by hand start moving this circle around and checking where the boundaries are. So it looks like 0.6 and -0.6 are the X boundaries to get the ball completely out of range. And I'm going to assume it's probably very similar for the top and bottom. Yeah, so it looks like 0.6 gets us up to the edge, and -0.6 gets us down to the bottom edge. So I can go back to my math chop, and I'm going from a range of -1 to +1 to -0.6 and +0.6. I can then finish this chain with a quick null so that my reference is nice and stable here. Activate that viewer. Drag the X channel onto the overtop's translate X, and do similar for the Y channel onto the translate Y. So now I essentially have this ball just randomly moving around the screen, which will be great so that I don't have to constantly try and play with the content myself, which can definitely get tiring in long development sessions. And now we're ready to essentially start building our feedback loop and start thinking about how feedback loops work. Now, I always say a great way to think about it is, it's not called a feedback loop for no reason. It essentially is a circular, recursive loop of data getting processed. And I like to visualize that even inside of my setup here. So one of the ways that you're commonly going to see this feedback loop set up is that first you're going to have something like a composite. I think that's the more common one. And you're going to have your source going into the composite. And then you're going to make a feedback top. Because one of the challenging things about feedback is we can't literally just grab, the output of a wire and plug it back into something earlier, because it's going to give us a big error that says warning, cook dependency loop detected, and that's going to make your network have all kinds of problems. So we actually have to use this feedback top to create that loop back point for us, because what it does is it gets the last frame's data, which then avoids any of these recursive programming issues and gives us the feedback loop effect without the programming problems. So the feedback top is really great because what we can do is plug our original source into the input, which technically really won't ever matter unless we hit this reset button. We're going to take the output of it and plug it into the composite. And what we're going to do is in the target top parameter here, we're going to tell it where it's going to go and pull data back to create that circle. So in this case, I'm going to grab this composite top and drag and drop it onto that target top parameter. And this kind of little circle we see here between the reference line of that composite sending its data back to the feedback loop, to feedback top, I should say, and that feedback top outputting its data over the wire into the composite, this is essentially our feedback loop here. This over on the end, this output of this is really just, some eye candy, some cherries on top if we want to over it or do anything like that. But the feedback loop essentially exists right here where my mouse is. And this is really important because we're going to talk about this wire in a moment and how it's special and different when we're conceptualizing how the processing works on that wire. So the last thing I want to do before we start diving into some fun stuff is by default that composite top is set to operation multiply, which is not particularly useful for this feedback loop. And you'll find a lot of times people will either set it to something like over or add. Those are kind of very common composites inside of this feedback loop chain. And you can see once I set this to over, what's happening is that every frame, this circle is moving and being composited onto this composite top. That composite top's source is getting read and fed back into the feedback loop, which then feeds it back into the composite. And the effect that we have now is essentially this perpetual drawing on the screen of this circle. And we can see it never clears. And I always say a good way to think about this is if you come from a processing background or an open frameworks type background, that idea of I'm drawing a circle every frame and moving it around but not clearing the screen every frame, that's like a very similar effect that we have here. Now, this wire I mentioned is very special, and it doesn't look special because it looks like just like every other wire, but it's definitely special because any effect, any top, any operation we put in here, unlike the operations we might put anywhere else in our network, become recursive. And this is a really important concept, so much so that I even have trusty MS Paint, which, I'm going to say MS Paint looking real nice in Windows 11, looks real clean. But I'm going to draw a couple little charts that I find a helpful way to visualize what's going on. So normally when we add something like, let's just say, for example, a level top. If I add a level top between my circle and my over, and you don't have to follow this part because we're going to delete it in a moment. If I do something like lower the opacity to 0.9, what happens is this data from the circle comes into the level, one time gets applied that reduction of opacity to 0.9, and then it feeds through and just continues through. Now, what happens if I do the same thing on this wire here in between my feedback and my composite? I'll go ahead and add a level here, and I would suggest doing this on your project as well. If I set that opacity to 0.9, all of a sudden I got trails. We're like, what? And I think this is what kind of starts to hurt the gears in the brains of many folks that are getting into this. Why does this give us trails? Now, the reason is, if you think about every frame's lifetime individually. Inside of this feedback loop, without that level, they're basically fully additive, so no frame ever disappears. Now, what happens is when we set this level top on this wire in the middle of our feedback loop and set the opacity to 0.9, you almost have to start thinking about the lifetime effects that a frame is going to accumulate, because every frame, that same frame of data, is running through this loop. So actually, unlike when we put it after the circle where that 0.9 opacity was applied just once, as every frame passes, it gets another 0.9, 0.9. So every frame, the frame of data that we're going to talk about, and we can pick any frame, but if you think about an isolated frame, as every frame of time passes through my project, it continues to lower its opacity down by increments of 0.9. And I think this is a really important thing to internalize because, for example, we can think about a very simple Microsoft Paint graph here where it's time and effect. And I think thinking about this concept of the effect being applied over time is what's really going to unlock your creativity. And you're going to see once we start doing some fun stuff in this feedback loop. For example, in this case of opacity, what happens is if I start my frame at a full opacity here, every single frame that passes by, it gets an opacity applied of 0.9 all the way until over time it reaches that value of 0. And this is essentially the creation of the trails we're seeing. It's that as the circle gets drawn on a frame, it enters the feedback loop, and then for every progressive frame that it continues going through the feedback loop, it slowly has its opacity ramping down. And the lower I put this, the faster those frames ramp down over time. And the higher this value is, so the closer to 1 it is, you can see then our trails become very long, because if I go back to my chart, instead of going down kind of like this, if this was, for example, 0.9, now they're kind of ramping down very, 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 very slowly. And then if I set this value to be, for example, 0.3, now we're thinking about this original frame of data over time just completely having its opacity removed very quickly. So don't mind how ugly my MS Paint sketch abilities look. I'm not an MS Paint artist by any stretch, but I think this idea is really important, where instead of thinking about what does the effect do and why is it magical, we think of this idea of what happens if I do a certain operation recursively over and over again on a frame of data. How does that affect it over time? And we're going to see some of these questions get answered with some really common effects here. So already one of the most common things you'll probably want to do is insert a level on this wire, because that's going to allow you to have the older data inside of that feedback loop fade out over time, which is very useful because otherwise the screen just gets completely full. Another very common thing you'll see is this idea of blurring and adding a recursive blur so that every frame, whatever data was there, just keep blurring out into infinity. And this gives a lot of feedback loops a really great soft feel to them, kind of like an airy feel. So we can see as I'm looking at the output here, if I turn this higher and higher, it gives it this really nice wispy, so not only is it fading out, but it's also kind of blurring out over time. And if we go back to our graph here, and let me switch my color. So the black lines I drew were the opacity, but I can also think of blur starting from no blur, and then every frame, that blur keeps getting added and added on top. And then what happens is as the opacity is ramping down and the blur is ramping up, we get this cross of this beautiful, nice fade out effect here. So that's a great thing that a lot of people do. And like you're seeing here, this mindset of what happens when I apply an effect recursively, that's the kind of mindset that's going to make you really successful with feedback. And especially knowing that this wire, this is the magic wire where we put all of our feedback effects on. So another really interesting thing that people do with feedback loops is thinking about recursive transformations. So for example, if I put a transform top on this wire, and I think to myself, well, what happens if I add a tiny, tiny, tiny bit of translation on the X? Now it seems like there's almost a fake wind blowing, because for every frame of time that passes, all of the older frames of data are just keep They're continuously getting dragged and dragged and dragged to the right. And that's fun. I don't think that's often used. What is a really cool thing we can do here is play with the scale. Because if you think of this idea of zooming in and out as an effect that could be added on the feedback loop, if I do something like increase my scale on the transform stop, even just ever so slightly, you know, like 1.01, so just that increment of adding 0.01, now you can see all of this kind of feedback trails has this almost smoky effect, like it's coming towards you. It's coming towards the user. And that's because every frame of data over time just keeps scaling up until it has been ramped down from the opacity and kind of blurred out to nothing. Now we can also do the same thing in reverse. So let's say we want something to feel like it's traveling away from us. We can actually bring this value just below a value of 1. And just having that tiny increment of every frame things are getting a little bit scaled down, you can see it feels like things are getting sucked into that middle of the screen here. And I can exaggerate this just so we can see. It feels like no matter where that trail is coming from on the circle, it's kind of getting sucked back into the center of the screen. So these two things are really, really fun. But just to show you the idea and power of thinking about this recursive effect and, you know, this effect of what happens over time. So you can have a lot of fun with this feedback wire here just by trying to add in different effects. So I'm going to delete the blur and the transform and just going back to a kind of raw circle with a little bit of trail on it. What happens if I do something like insert and emboss? What if I every frame emboss the frame that was embossed repeatedly? You know what? That's the kind of thing that starts to get exciting. And now I will say, when you're working with feedback loops, oftentimes you're really going to have to experiment with the parameters because the default parameters are usually set for not feedback loops. And inside of feedback loops, I find that effects are either way too strong and it goes crazy instantly, or they're way too weak and you don't see anything visually. So in this case, I almost don't see any kind of visual difference in my output here of my composite, of my feedback. So I'm going to start turning up the strength. And now I'm starting to see some trippy behavior here where it's embossing every frame recursively forever, which is essentially a moire generator. If you wanted to generate some moire in TouchDesigner, lo and behold, we can basically plug anything in and get some very, very strong moire effects. Almost mesmerizing. You know, it's a good thing I had a coffee before this. Otherwise, I would very much be lulled by the moire here. So that's a cool thing. So now we're starting to think, well, embossing this over and over again kind of gives it this moire effect. What about some other interesting things we could try? What about doing something like maybe adding an edge detection? What happens if every frame we edge detect every frame that was also edge detected before that? Now, this is a great example of an effect where the edge by default actually starts off with parameters that are so strongly tuned that it just basically instantly becomes noise on the screen. So this is one where, unlike my emboss where I was turning up the strength, I really want to immediately just turn that strength down to 0 and slowly start ramping it up and watching what happens over time. And now I can see, oh, interesting. So it's making a kind of cool outline trail, kind of looks like a Sonic type of vibe. Oh, and then the outlines start to remain because every frame, it does an edge detection of the previous frame's edge detection. And you can start to see as I start to turn this up, we're almost getting to the point of making these kind of, what's they called? I'm brain farting on the name of the noise effect where you plug in a noise and you feed it back on top of itself over and over again. Very cool effect. And this is how you start to think about that, because what you would do is take some noise data, maybe you could switch the input from this circle to a noise, have it do an edge detection, and then repeatedly do the edge detection on the edge detection of the previous frame. And that can really unlock like the creative power. You can see even with 4 or 5 nodes, there's a really interesting effect happening on screen with these edges, and it looks kind of fluid, like you're kind of parsing through these waves that are in the background. Lots of really fun stuff. We could even start to think about what happens if we recursively do something like a tiling operation. So in this case, you know, we use tiles when we want to do things like kaleidoscopes. But what if every tile gets tiled every frame in a feedback loop? Well, then all of a sudden one ball becomes something like this, which is pretty crazy because the original circle moving is this one in the middle. And then when it first gets tiled on the first pass of the feedback loop, we can see we got the 4 circles here next to it. But then those 4 circles get tiled, which then become the 4x4 grid of circles behind it. But then that gets tiled the next frame, and you can see it over and over again until this kind of just does an insane perfect grid of circles, almost like you're instancing without needing any instancing. And then you can start to have fun with things like, well, what if I go to the tile options, maybe turn on the reflections. And now you can make these really interesting patterns. And by all means, you can compound these effects. You can take this effect, plug it, add a feedback in here, add an edge, add any of those kind of things that you wanted to add. So I hope this really helps you kind of dig into feedback loops a little bit better and give you some opportunities to explore with your own kind of creativity. If there is one thing you're going to take away from kind of what we did here, don't worry specifically about what we were drawing, but just this idea that when we create this feedback loop, that the wire that we have available to us kind of becomes special, even though it's technically not special. It becomes special because any operation we add in here becomes an operation that recursively happens every frame on all the data. So in the case where we do something like have a level, it's going to fade out that data over time. When we have something like a tile, every frame, it just kind of tiles itself into infinity. And we think about any of those effects happening over time gives us that ability to think creatively about, well, what is something interesting that we could add here? You know, we talked about that blur example where it starts from blur 0 and then eventually all the content blurs out into nothing. If you start to approach feedback loops thinking like that, I think there's a lot of fun and creative things you can do with them, and I hope this gives you a head start.
Hey guys, thanks for watching. If you're serious about taking your TouchDesigner and interactive skills to the next level, I highly recommend you check out the Interactive and Immersive HQ Pro. It's the only educational resource and community of its kind for TouchDesigner and interactive professionals. You can learn more by checking out the link in the description. And if you like this video, don't forget to hit that like button. And if you're new here, don't forget to hit subscribe and the little bell icon for more awesome free content.